This is electrolysis versus mole concept. This question is so technical and we are going to solve it step by step. Calculate the volume in dm³ of oxygen evolved at standard temperature and pressure when a current of 5 amperes is passed through acidified water for 193 seconds. Take 1 Faraday as 96,500 coulombs per mole. Molar volume at standard temperature and pressure as 22.4 dm³. Now, first of all, solve this. Pick the right answer. Type it at the comment section as we solve this the chemist AI way. Stay tuned. If you see questions like this, the first thing you should do is to jot down the givens. We were given current as 5 amperes. We were also given the time of passage of the current as 193 seconds. We were also given 1 Faraday as 96500 coulombs per mole. We are also given the molar volume as 22.4 dm³. Now, before we go further, understand something. This 96,500 coulombs is the quantity of charge per mole of electron. So this per mole, this mole is mole of the electron, but we don't know how many moles of electron involved here because this is just a standard. We are now going to calculate how many quantity of charge that is involved in the number of moles of electron in this question, because this is a standard. That quantity of charge is equal to current times time. The current is 5 amperes and the time is 193. 5 times 193 will give you 965 coulombs. We know that 96,500 coulombs is for 1 mole of electron. Now, this is the quantity of charge in this experiment. How many moles of electrons are involved? Let us find it out by stating that 96,500 coulombs liberates 1 mole of electron. Therefore, 965 coulombs would liberate how many moles? You express it in proportion 1 over 96,500 times this 965. You are going to get 0.01 mole of electron. Let us now talk about how many moles of oxygen involved, because the number of moles of electrons determines the number of moles of oxygen evolved. How do we do that? We are going to bring another standard. This time around, it is not this. We are going to write the equation of electrolysis of acidified water to find out how many moles of electrons and how many moles of oxygen are involved at a molecular level, right? So from there, we find out the number of moles of electron and oxygen in this experiment. So let's do that. You write the equation of reaction, that is electrolysis of water. If you don't know how to balance the equation, you are definitely going to stop at this level, but it is very simple. Now let's start from hydrogen. Hydrogen is 2 here and 1 here. You write 2 here. Oxygen is 1 here and 2 here. You write 2 here. Because you wrote 2 here, hydrogen has increased to 4. You write 4 here. But the charges are not balanced. The total charge here is 0. The total charge here is plus 4 and 1 minus. So you have to write 4 here so that we have 4 minus. So that we have plus 4 here and minus 4 here balanced. Right? So the equation is balanced. And this equation is actually telling us something. It is giving us the information that at a molecular level, 4 moles of electron is involved in discharging 1 mole of oxygen. Every 1 mole of oxygen is discharged by 4 moles of electrons. Now look at this important comparison. The equation has brought us the standard that to every 1 mole of oxygen, 4 moles of electrons are involved. But in the experiment, we have calculated that there is 0.01 mole of electron. Now let us calculate how many moles of oxygen involved by relating this with these 2. We have 4 moles of electron. Is involved in liberating 1 mole of oxygen. Therefore, here 0.01 mole of electron will be involved in liberating how many moles of oxygen? You do the same proportion, 1 here over 4 here times 0.01. You are going to get 0.0025 mole of oxygen. Finally, calculate the volume in dm³ of oxygen involved at STP. And you know that this volume is the volume that is liberated by 1 mole of any substance at all, not only oxygen. This time around, we are talking about 0.0025 mole of oxygen. So there is another comparison to make, the final comparison. This is giving us the information of 1 mole of oxygen, right? So 1 mole of oxygen occupies 22.4 dm³ at STP. Now, at the same STP, how many dm³ of oxygen is being occupied by 0.0025 mole? So you say 0.0025 mole would occupy, you do the same comparison, 22.4 over 1 times 0.0025. When you multiply, you are going to get 0.056 dm³. This is the volume evolved at STP when 5 amperes of current is passed through acidified water for 193 seconds. Therefore, our answer is D. If you found this video useful, click on like, comment, share the video, tag your friends, follow and subscribe to my YouTube channel.